So now we're going to talk a lot more about factors. So x to the 1 power is the same thing as x. That's what that says. X to the 1 equals x. The number 1 in the exponent just says that there's one factor of x in that term. One factor of x. If it's a positive number in that place, you could have a 2 or a 3 or a 4 where the 1 is, up here in what we call the exponent. Sometimes we call it the power. Oops, I can't get my pointer to go in the right place. There we go. That one there. If you put a 2 there, it means you have 2 factors of x. If you put a 3 there, it means you have 3 factors of x, etc. So this exponent here is, this number here is just counting the number of factors of x if it's a positive integer. If it's a negative integer or some other number, then it means something different. But you can still think of it kind of the same way. So x squared is x times x cubed is x times x, and those are just common words we use for that. X with a 2 up here, we just call x squared. It has to do with the area of squares, and x cubed because it has to do with the volume of a cube. So you just get used to that, square, cube. Any higher number, we just say like x to the 4th power. We've used the word power. This is sometimes called, it's called an exponent, it's also called a power. X to the 4th power, x to the 5th power, x to the 6th power. You know, after square and cube, you just use the number with a th after it. 5th power, 6th power. So, since this number is just counting the number of factors of x, if you have x squared times x cubed, this means 2 factors of x times 3 factors of x. So how many factors of x do you have? You have 5. 2 from here and 3 from here makes 5, right? So when you're multiplying these, x squared times x cubed, you add the exponents, okay? Notice the number in the bottom, this is called the base. The number in the bottom, this is called the exponent or power. The base is, if the bases are the same and you're multiplying, you add the exponents. And even if these were weird numbers, you just think of 2 and 3. And whatever the number, like if this was square root of 2 and this was pi, you would just think, well, if it was 2 and 3, I would add them to get 5 because there's 5 factors. So I'll just add the square root of 2 and the pi, and you get x to the square root of 2 plus pi. So you just remember this example, and it gives you how to do all of these. So this is the general rule. We put letters in there instead of the 2 and 3. But the smart way to remember this rule is just to remember how 2 and 3 works and why. 2 factors of x times 3 factors of x gives you 5 factors of x. How did I get 5 from 2 and 3? I added them. So if I have other numbers, I just add them. And this formula here works for any real numbers m and n, right? M could be a half and n could be 3 halves. And you add them and you get 4 halves, which is 2. So that'd be x squared. You just add the exponents. Okay? So that's a super important rule you have to know. But all it is just understanding factors. That's all it is. So x squared cubed, that's what this says. This says you're taking 3 factors of x squared. 3 factors of x squared. So x squared times x squared times x squared. So you add these exponents by the rule that I just had, right? And you get 2 plus 2 plus 2 is 6. Now how do you get from x squared cubed to 6? You multiplied the 2 and the 3. See? So this is when you multiply the exponents. When you have x to some power, and then you take that whole thing and raise it to some other power. Then you multiply these 2 exponents. The exponents right next to each other, right? Separated by parentheses. And you just multiply them. So that's another rule. So these are rules of exponents, they're called. And it's super important. You have to know these. you'd be real comfortable. So just come back and review them every once in a while. If you tend to forget them, just keep reviewing them. The most common thing is people get these two backwards. When do you add, when do you subtract? But if you can remember the meaning here, well, I have 2 and I have 3 factors, and so altogether I have 5 factors, so I add here. Then the other one is the one where you multiply. That's another way to remember which one's which, right? So try not to get those mixed up. Now, if you're dividing, what does that mean? Well, x to the 5th means x cubed times x squared, right? X squared. I wrote this as with the x squared because then those are the same. And 2 plus 3 is 5, right? So then the x squared over x squared cancels, and you just get x cubed. So what is actually happening is you're subtracting and you're subtracting the exponents or powers. 5 minus 2 is 3. So if you're dividing, you subtract these. And so that's this rule here. Okay? It just comes from the fact that this just tells you how many factors there are. Now, what if you had a higher power on the bottom, a higher exponent on the bottom in the denominator than in the numerator? Well, you could use this rule. This doesn't say n is bigger than m. It just says subtract the two numbers, whatever they are. So you could use that, and you'd get x to the minus 3. Or you could write the bottom x to the 5th as x cubed times x squared, and then the x squares cancel. Now remember, when you cancel x squared on the numerator, you need to replace it with a 1. We didn't need that here because x cubed over 1 is just x cubed. But if we cancel these, we get 1 over x cubed, which is not the same as x cubed, right? So if you cancel those, remember when you cancel by dividing, you get a 1, right? So you could get that. So that means the same thing actually as x to the minus 3. So you can, this is slightly different. So in this first rule here, I wanted my answer to be in the numerator. The denominator is just a 1 that we don't usually write here, right? So I took n minus m. Now, if I wanted my answer to be in the denominator under a 1, then I would, instead of taking n minus m and putting it on top, I would take the m minus the n and put it on bottom. See? So notice the one that's moving, the x to the n, this goes down in the denominator. The sign of the exponent changes to a negative n. This one, the x to the m's going into the numerator, and it changes signs. So whichever one is changing from numerator to denominator or vice versa, it changes signs. And the other one stays the same. See? This x to the m stays in the same place, so it's still x to the m. So the minus goes on the n on this one. Okay? So look at those for a while and make sure that you understand them. And write out some examples like this with just integer exponents so you can see what's going on and get comfortable and confident with it, if you're not already. Okay. If you have m is 0 in either of these equations, or say in the first equation, m is 0, right here, then you get x to the n minus 0, which is x to the n. So, wait, that doesn't help. I'm sorry, I wanted the second one. So if you put m is 0 in here, x to the 0, then here you'll have 1 over x to the 0 minus n, which is x to the minus n. So this tells us that x to the n can be written as 1 over, or the reciprocal of, right, x to the minus n. So if I move this x to the n from the numerator to the denominator, which leaves a 1 behind, the exponent changes signs, not the coefficient, which is just 1 here. The exponent changes signs. Okay, and the same thing works right this way. This actually means the same thing. Because nobody ever said n was positive, right? So notice here you have a negative exponent, and this is the numerator. The denominator is over 1, right? But you want to move it to the denominator, so you move it down, and it changes sign. The exponent changes sign. It went from negative to positive here, and from here it went from positive to negative. You can also go right to left. If you have 1 over x to the n, you can write it as x to the minus n. If you have 1 over x to the minus n, it's actually simpler to just write it as x to the n. Right? So those are important rules for exponents. So if you make n equal to 1, you get this. And what this says is x to the minus 1 is the same thing as 1 over x. And x is the same thing as 1 over x minus 1. So 1 over something is a reciprocal, right? So x to the minus 1 means the reciprocal of x. This is the reciprocal of x, 1 over x. X is the reciprocal of x to the minus 1. So x to the minus 1 and x are reciprocals of each other. That's what these two things say. If that's a little confusing, just keep looking back at it. And when we actually go to use it, hopefully it'll it'll be clear in your mind. So I did this example, x cubed times z over a equals z over x to the minus 3a, right? So I'm just showing that if you wanted to move the x cubed from the top to the bottom, it has to be a factor, not minus or plus, but times. You can do that. You just have to change the sign of the exponent to the opposite sign. Right? Now, if it was x cubed to begin with down here, this is different from this. If it was x cubed on the denominator to begin with, x cubed is a factor of the denominator, then we could move it to the top if we wanted to, and we get x to the minus 3. So if you move a factor from the numerator to the denominator or vice versa, denominator to numerator, you have to change the sign of the exponent. That's all that's saying, right? That's just an example. Okay, what did I do? I took x squared and x to the fifth are the same, so you can think of it as peeling off x squared out of this, x squared times x cubed, and cancel the x squares. Or you can subtract the 5 minus the 2, right? And the positive one is where it ends up. So 5 minus 2 is 3. Or I could have done, this is the same expression here, right, as this one. I could have, if I wanted the x's to be on top, I could take 2 minus 5 and get x to the minus 3. So on one of them I'm using this rule, and one of them I'm using this rule. I think the first one I'm using this one, the second one I'm using this one. Okay. So these rules work for any real numbers, not just positive integers. But it's easier to understand them with positive integers. So that's why I did the examples that way. Know all these rules. Know them. Keep going back to them if you can't remember them all at once.